Hey, I'm just getting back to the studio, so...
I almost forgot. There was a package delivered. I put it in the studio for you.
Oh.
I'll see you tonight. Bye.
Bye, babe, thanks. What the heck is this?
MandicReally. We hope this package finds you well. Enclosed you will find the new Drop Effect XG hotend. Is this a revolution in additive manufacturing? Only rigorous lab testing will show for sure. We look forward to seeing what you Frankenstein together.
This is Project ReAniMaker, what I have dubbed a RestoMod 3D printer, taking an original MakerBot Replicator with its wooden box frame from 10 years ago and turning it into something entirely different. I debuted this at EarF 2022, and now it's time to give you a full breakdown of what's going on inside of this machine. For anybody who's unfamiliar, this original MakerBot Replicator came as a kit that cost you about $2,000 US, and yes, the wooden frame is how it came. This particular one was a dual extrusion model with 2 extruders mounted on the carriage that I picked up off of Facebook some years ago. Got terrible print quality out of it. One of the extruders wasn't acting properly. It had some shorted wires, and I put it on the shelf and have never really done much with it until it came time to build this. My original intention for this machine was to upgrade the mainboard in it, install an E3D V6 and some part cooling that I designed for it myself, and make it my fastest 3D printer. At the time, I only owned a couple of Ender 3s, my Ender 5 Plus, so calling it the fastest 3D printer I had would not have been a very high bar to clear. With the experience that I have from newer and faster machines and all the builds I've done since I picked this thing up, it had to change and it had to be something different. So let's break down the parts that are at play here, and then we'll talk about the actual design intricacies of this machine. Let's start off with the thing that I mentioned in the intro skit, the Drop Effect XG Extreme Gradient Hotend. Quick note, this is not a review of the XG, and it is not sponsored by Drop Effect. They did send me this hotend pre-release. I had a machine that it was going to fit in really nicely, so I used it, and I think it's neat, so let's discuss it. This thing weighs in at 40 grams, which is about 10 grams lighter than the E3D V6 I intended to use in this build previously, has a large copper heatsink, and what they're calling a kinematic mounting system for the hotend heat break setup. It basically decouples the heater cartridge from the frame and allows for expansion and contraction while still really solidly holding the hotend in place. I found this had a bit of a side benefit the way it's designed, in that I was able to remove just 2 screws and remove the heatsink, heater core, heat break from the frame without having to disassemble anything else about my printer. I was able to dangle those down and clear out a clog, having really good access to these parts. The heater element on this is a all-encompassing design that surrounds the nozzle, similar to, say, a Fadis Rapido or a E3D Revo hotend. Unlike those other units, this does have a serviceable thermistor, so if it burned out, you wouldn't have to replace the entire heater core, or if you want to swap from the one that it came with to something like a PT1000, you could do that here. The one thing I can say that I understand but I don't love here is the nozzles. They are an M4 threaded nozzle, meaning they are a smaller diameter than your standard reprap nozzle, and to my knowledge, they are only currently available from Drop Effect. The reason for this is the smaller diameter means that the heater element is closer to the filament path to transfer heat more rapidly and more efficiently. This should lead to higher flow, and along with that, it also has a mid-length nozzle to it. It's longer than a standard RepRap V6 type nozzle, but shorter than a current Volcano type nozzle, so it can still fit into this compact package. One thing I can say about the way all this design comes together is the serviceability. Like I mentioned, dropping out that entire assembly is easy to get in there and work on it, or one-handed nozzle changes. A lot of hotends claim to be one-handed change, but honestly, I find you still want to hold them with a wrench or something because they just don't feel quite that stable. This truly feels rock solid stable. I had zero issue changing nozzles on this one-handed. The only other thing I can say that with is the E3D Revo, which is designed with that as its core idea. I feel like I'm sounding a bit too much like an ad at this point. I'm impressed by my initial impressions of this hotend. That's the best thing I can really say for it. Now let's move on to talking about the rest of the hardware in use here, such as the extruder that I used is an NX Engineering Micro Sherpa. This is a 3D printable housing extruder that uses Bondtech BMG gears. It's very light, compact assembly, which fit the overall build that I was going for here really well. This runs a little Pancake NEMA 14 17mm stepper motor on it. I'm running a Phystech motor right now. Now these are known to run hot, so I used polycarbonate for the main frame and ASA for some accent pieces on this extruder. And I took inspiration from the Voron V0, as I did many places on this build, for this cable management piece on the backside of the motor of the extruder assembly. For the motion system, the hardware kit, the belts for this setup, I ordered Voron V0 parts for a Voron V0 build. So I used those pulleys as part of my design elements and the dimensions of the belts from a Voron V0 as well, though obviously not all of the geometry or anything because it's a totally different machine. The AB, aka X and Y motors, and the Z motor on this build are all the original stepper motors from the original MakerBot Replicator. They were the X and the Y motor, and the Z motor still is the Z motor. This might have been a mistake, and we'll talk about the things I think I want to change toward the end of this video. And I actually robbed a Voron V0 anti-backlash nut out of a kit I have here in the studio. That's a whole nother video coming real soon too. The bed assembly is also original to the MakerBot, except I bypassed the thermocouple it would have had on the bed rather than trying to figure out the wiring. I went the Prusa method and just taped a NT100K to the bottom of it. And that being a 24-volt wired bed, let's talk about the electronics in this thing. The main board I'm running is a Big Tree Tech SKR3EZ board. It has those weird slot-in TMC 2209 stepper drivers that I'm running. I chose this board because I had two of them, and also I was worried I was going to end up with these older motors running a lot of motor current, and I knew this board would be capable of handling that type of current output versus some of the other ones I had available to me. However, I did decide to forego using the onboard MOSFET for the bed heater. For that, I went to an external MOSFET. The reason I did this is because I'm using the original MakerBot Replicator bed, I have no idea what power draw that bed has new, and if there's like any degradation of it, there's a potential it could draw more power, and I really didn't want to burn out the MOSFET on the board. I'd rather use the external one and risk that versus my main board. For power supplies, we have two of them in here. We have the Meanwell 350 watt that is supplying the 24 volt to this system. The other power setup is a 24 volt to 5 volt converter that I'm running to power the Raspberry Pi that has Klipper running on it. But the astute among you might have noticed I mentioned Raspberry Pi. Where is it? Well, it lives in this cute little tube television. Fairly early on, I came up with the name Project ReAniMaker based off of the Reanimator movie, and as such, I wanted to have a bit of a B-movie, kitschy feel to certain things, such as the army green and orange color scheme of the printed parts. The wooden box frame design kind of just screamed it to me, and so I designed up this little tube TV Pi case that has a Big Tree Tech Pi TFT 50 touchscreen inside of it, and mounted to the backside of that is a Pi 3 Model B. Taking a closer look at this thing, there's a lot of design elements in this little thing. It's got my RLY instead of an RCA logo on the front of it, a couple of tuner knobs that don't do anything, and the rabbit ear antenna on top that is one of my MandicReally logos. There are various vents around this thing. There's one on the faceplate of it, one in the side panel, and a couple in the back panel of this whole design just to keep ventilation and airflow moving here. Along with that, the back panel is removable for easy access to the Pi, but it also has a 40mm 5-volt fan inside of there to, again, keep the Pi cool and flow air through it. I'm absolutely going to release the files for this case because I could see people using this as just a fun little Pi computer setup. Use this screen with a Pi mounted inside of there, hook up a mouse and keyboard, and you've got a kitschy, fun little display computer. Thinking about the complexity of a project like this can be overwhelming, and I have to step back and thank my patrons on Patreon. It is thanks to you folks that content and projects like this are at all possible. The Fusion 360 file for this build is like 66 versions deep. Design time, project build time, parts, none of that would be possible if it wasn't for you folks, so I have to say thank you. If you're not already a patron, please consider checking it out at the link in the description down below. I do some exclusive 3D designs. It's a great way to get input on future content, ask questions you might have, or just help support this content. Even $1 a month can go a long way. Please consider it. And if you can't justify it for free, you could drop a like on this video or subscribe to the channel to help support as well. The design process for this project was like a tongue twister meets a puzzle meets a riddle. I thought at many points that designing my own Core XY system was going to make me go cross-eyed. The absolute MVP of this entire project was open source. Because the original MakerBot Replicator was still an open source project, I was able to get the original SolidWorks assembly CAD files that I could open up in Fusion 360 and build off of. If I had to measure and make everything from scratch, it would have been too time intensive because it was already extremely time intensive to do this. The other star of this process was the Voron design team. The Voron V0 file that I had loaded up in Fusion 360 allowed me to reference quickly if this belt should be turning this way, that way, which one should be crossing how. Just anytime I got a little turned around and confused, I was able to refer to that and at least get some bearing as to where I was heading. The MakerBot Replicator uses 8mm rods and linear bearings to make up the motion system on it. So I started my design process with the Y carriage end pieces because they had to, one, include the bearings on the top of them and encompass the rods on the bottom of them. So if I could get the fit right on the rods and the bearings with my printed parts, I knew the project was viable. I got to work iterating, designing, printing out parts over and over again, just printing the parts that had to fit onto the rods, printing the parts that had to clip onto the bearings. I printed them in the Polymaker ASA that I knew I was going to be using for my final parts, so shrinkage was factored in, and the machines I was actually printing on, their tolerances were factored into my design. Once I had the very rough mock-up ones that were nothing like I knew the end pieces were going to be, I just needed to ensure I could get this carriage moving, I was able to move forward with belting and that entire process. And that was a process. I literally made clones of the belts from the machine and just oriented them, turned them, placed them where I knew they would need to be for a Core XY system to function. Honestly, the way the design process went and usually goes is place an object where you think it needs to be or where you know it needs to be, and then connect A to B. Draw lines in between them, create objects, which honestly I should really be doing Fusion 360 tutorials at this point. Maybe my ways aren't the best ways, but they work pretty darn well for me. What do you think? Let me know in the comments down below. And in this case, it was also a lot of prototypes. These were just the ones I was able to quickly find. We recently did a studio cleanup, and I think a bunch of the other ones ended up in a box somewhere. That's kind of what it has to come down to. It all looks good on paper until you actually print it out and realize, oh, I can't install a screw the way I thought I could, or heat press insert, or the rod doesn't fit quite right despite the tolerances working previously fine. My favorite little factoid about this build is the X carriage itself. The carriage, the hot end mount, the hot end extruder, fans, part cooling duct, all of that stuff assembled, sitting on the scale, weighs in just 3 grams more than one of the original extruder motors off of this MakerBot Replicator. And remember, this was dual extrusion, so there were 2 of those motors, there were fans, there was more going on there. So I'm likely somewhere around 30 to 40% the original weight on the tool carriage for this machine. Once all the prototyping was done, I thought I was ready, it was time to hit the ground running on assembly because Earth was breathing down my neck. Unfortunately, that meant that I was not able to film the build process nearly as much as I would have liked. I would never have gotten the project done for Earth if I spent the time filming it as I went. It just adds so much more time to projects. On such an ambitious project, I was never going to get away without modifying the case of the replicator. As such, I created a couple of drill jigs that I was able to bolt onto existing holes on the body to line up exactly where I needed to drill for new mounting holes for mounts and holes to pass the belts through to get to the motors in the back of the body. It was the simplest way I could see to do it and get it accurate, and it worked out really well in practice. I need to share how getting this thing to Earth went. The night before I needed to head to the show for load-in, I was up until 4 a.m. getting this thing moving under its own power. Not printing, just moving. I didn't get this machine printing until midnight in my hotel room the night before Earth opened. I already set up my table at the show floor and went back to my hotel room with this machine, got it printing. And the very first print I did was a short, fat calibration cube that was 25 millimeters on X and Y and 20 millimeters on Z. Now I can count the number of things I have printed on this machine so far as of filming this video on both hands. And the print quality is not amazing. It's not terrible by any means, but it's not nearly as good as I would like to see. The most recent print I did on it is also the largest print I've done so far, and that's my ghosty can cup design using this Cookie Cat unicorn filament. This thing turned out overall really pretty good. It has some salmon skin type look to the outside of it, and I think I know what that's down to. You see, despite the fact that on the Y carriages my linear bearing mount was solid and tight, for some reason on the X carriage they're loose, so I can actually wiggle that on the bearings just a little bit, but enough to, as it's slinging back and forth, likely introduce inconsistencies. That's my best guess on what's happening, and I intend to update the X carriage to fit these just a little bit better. But mind you, that ghosty printed in 5.5 hours. I used a Voron V0 profile in Prusa Slicer, modified the bed dimensions, and a couple of little tweaks here and there in the settings to match the Project ReAniMaker, and it's just been printing like that. It's been running Voron speeds and accelerations with little to no tuning so far. Realistically, the only things I've truly tuned on this machine so far is the E-steps in Klipper, its rotation distance. I've dialed that in on this machine, and I've dialed in the pressure advance, which is their version of linear advance, so my extrusions are a little more consistent at the ends of layers and around corners. But here's where I need to talk about the things I would do differently. Realistically, not a whole lot. I mentioned that X carriage needs the fitment adjustment on it. That's not a big deal. I probably have a few minor fitment tweaks on printed parts like that. The belts are mismatched in this. I have one Gates belt and one super cheap Amazon rubbery belt that's terrible and makes this awful noise. I think the biggest thing I need to address in this thing is the motors in this build. The Z-axis is probably all right. That anti-backlash nut on the lead screw seems to have taken up all the slop in that, so that's probably fine. I found that while printing on the show floor at Earth, the X and Y motors were cooking on this machine. I used 0.8 amps as my baseline for the motor current on these, which I had found through multiple sources as the amperage that these motors should be running at, supposedly, from back in the day. I'm assuming maybe with their age or just the speeds that they were being pushed to, they had never seen that kind of action before. They just were not happy about it. And now I'm actually down at 0.5 amps with them. I'm not skipping steps that I can tell, but I'm worried that maybe I am skipping micro steps or something. It's causing some of my print inconsistencies along with the slop and the belt issue. Where I am skipping steps is the extruder motor. Feistek clearly states to run this motor at 0.35 amp. I ended up bumping all the way up to 0.425 amp just to be able to extrude at 10 millimeters cubed per second, which I think this hot end is probably capable of 20 millimeters, if not more. So I need a stronger motor on that. As such, I jumped onto Printed Solid and I've already ordered up some new LDO 0.9mm motors for the AB motors on this assembly. I haven't ordered the extruder motor yet. I think I'm going to push this one till it burns up, honestly, see what happens. There are plenty of things about this machine that I just don't know yet. I don't 100% know what the build volume is at this moment. I'm kind of just faking it. The speed limits of it, the flow rate on the hot end, what this thing can really do, I just don't know yet, and I'm kind of really excited to find out in a way that I haven't been about other projects in a while. This project was a lot of fun, and it served the exact purpose that I hoped it would. It turned heads at Earth 2022. Why'd you bring a 10-year-old printer?
Why is that thing made of wood?
It was a fun way to get people engaged with my booth and my content. As I said in the little feature video that 3D printing nerd Joel Telling did on this project, I could have brought a Voron, but I knew I'd be a dime a dozen. I brought a wooden box that prints like a Voron instead. There are absolutely improvements to the print quality and the speed and so many things I can adjust and change on this machine, but I'm seeing the potential there. I'm really happy that I took this thing from a shelf ornament that was collecting dust to a functional printer that I think I can actually see myself using on a regular basis now. And those are the broad strokes of Project ReAniMaker. I'll likely do a vlog or something like that when I get around to installing the new motors and the belts and tune this thing a little more. Maybe I'll do a little thing where we sit down and just do some print quality tests and all that with the updates that I intend to do to this when I find the time. Because I have plenty more projects and video ideas on the list to get done in the near future. A couple of more printer builds, some other related 3D printing build type stuff, some maker content, and upgrades to the studio, all coming to the channel in the near future. Alright folks, I hope you found this video interesting. If you did, please drop it a like, it really helps out. Let me know in the comments, what do you think of Project ReAniMaker? Is there anything I should cover more about this project? Let me know in the comments down below. Get subscribed to keep up to date with this project and future ones coming up, and to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. Thanks for coming around, folks.